Hey, Destin. What was it, Mouse? Zach, hello. Slim, thank you so much for the raid. Um, I'm kind of curious, Slim, if you get any philosophy questions. I kind of shouted you out to some actual like philosophy streamers, and like I've seen you say that like you're interested in philosophy too. So like, oh, I wonder if I can like make that connection. Um, oh, I freaking hell, I didn't turn my light on. Hey, syntax. Um, so yeah, I'm pretty sleepy today, so I it's probably not gonna be a super long stream, and I'm not gonna be on my A game, but uh, yeah. So Poison Mouse, you want to talk about mechanics? This is the book that I've been to talk about it. But I don't know if you want to, if you had a specific question or something, or what. No, it wasn't specific. Like, it wasn't a specific philosophy question, but no, I forgot to explain that. I canceled the session for today. It's gonna be a normal stream. Um, first with an S. I should make that an alias though. It needs to be. Let me just fix that now. I can make just first also work. Okay, they're done. Um, so yeah, we would be starting a new chapter for general relativity. I've read it, but I really just don't get it. And then Fenbox, the other person who's been kind of participating along at every week, is out sick, so just felt better to cancel it this week. Command for mice, best mouse in the world. I think we need to do a survey of mice in order to determine that. Hey Zeke, there's a lot of theorems involving circles that I've just never heard of. If you have a specific question, you can try me, but that's a little bit too general. Um, no, to Zeke. Hey Storm, Poison Mouse just wanted to talk generally about Newtonian mechanics. Um, I'm not really sure what, like, we're talking about torque, but I don't know exactly, like, I don't know, like, I had a hard time just, like, talking generally about it because I don't have a very good understanding of it myself. But, like, if there's too much words, yeah. um, I know, like, I was kind of assuming that you would have some type of, like, specific question, Poison Mouse. Uh, I mean, the proofs for circle theorems, Zeke, if you're going to be tested on them, then either you got to understand them and be able to do them, or memorize them otherwise. But if you don't need, if you're not going to be tested on the proof, you may as well just know the result and be able to use it. I know what GCSE is, like the UK's, uh, in American terms, is like the equivalent of a high school um, GED, I think. Yeah, sure, mouse. Yeah, sorry. It's just I always have a hard time with the question like, can you speak about this thing? Because I don't know the person's context. Yeah, I'm American Zeke. I the GCSE questions that I've seen I've been able to do, but I would need you to ask a more specific one, I guess. I don't know what I'm gonna do in the meantime. Uh, so we could look for more complex analysis stuff. I feel like I've kind of done all the chapter one questions that I was that interested in. I did it. I never heard of IXL. I've heard of Khan Academy. I've hardly used it for myself. Um, so I guess the answer would be Khan Academy. Storm, what am I doing in everyday life? I do a little bit of private tutoring, but for the most part, I'm just living off savings. I had a well-paying office job before I streamed, and I burnt out on that. And this has been what I've been doing to fill the time. Let me just bring this into Journal Plus Plus. I don't know why I'm doing it like this. Come to Portugal. That sounds lovely. I would love to go to Portugal. Yeah, I've done Project Euler. Paid IVK. For India specifically, they tend to do some really difficult math that I'm not too familiar with, so I have a hard time giving tips. But the general math advice I can give is there's no substitute for practicing things. It's annoying, but the repetition really helps. Okay, Mouse, do you want to do the physics or the complex analysis then? I know how to derive the Cauchy-Riemann equations, if that's what you're asking, or are you trying to do something with them? Let's do the physics first. Okay. Dude, why isn't my undo key working? I know why. No! Oh, I'm so stupid. Oh, fuck me. I just... I fucked up my tablet. Um, I deleted my... The, I deleted the keybinds that I had on my tablet without even thinking about it. Let me just set this up again quickly. How do I find the hotkeys? Okay, Control Shift P. Control Shift P. What? There. What did I think that was eraser. Control Shift E. That one was probably rectangle select. Control Shift R. This one was cursor select. Control Shift O. and that one was undo. Okay. There we go. I changed my name for a few reasons, Storm. I do more things than just math. Donda's Math feels like a very streamer-y name, where like just by seeing it, you can tell that I'm a streamer. And I just felt like I was always self-promoting when I typed in other people's chats. And then another big reason is that I'm not it's not a very original name, as I found out. There's a cat does maths who's been doing this for way longer than I have. At one point, there's also a Mark does math. So yeah, a lot of reasons. I'm not that crazy about Don Factorial, but it's good enough for me, and I more just wanted to leave behind Don does math. I could do that. I on Twitch, I don't like the idea of splitting up channels though. I feel like I'd rather make my Twitch channel just kind of like about me, and I like math, but I also like more things than just math. So, so what's up with number 6? A man of mass m stands on a railroad car that is rounding an unbanked turn of radius r at speed v. Yeah, Nightlight it does. The center mass is height L above the car. His feet are distance d apart. The man is facing the direction of motion. How much weight is on each of his feet? Interesting. I am Zach, yeah. um, dude, I'll never make the Olympics if I keep on dropping it. So this is weird. So for the weight on the feet, we would care about um like only the up and down forces on each of his feet. How does the rotational stuff play into this though? Because like that's going in a perpendicular direction, is it not? Like I guess I don't know, Dessen. Yeah, honestly, I don't know how to do this problem, I don't think. So do you just want to, so when it comes to the Cauchy-Riemann equations, do you just want to know the derivation, or like how to use them? You posted it? Oh, okay. Wait, holomorphic? I don't know what holomorphic means. That it's analytic? Uh, I have no clue, Nightlight. Analytic means that it has a power series, right? Like I could just apply the Cauchy-Riemann equations to that function, but I don't know if that's what the question is asking. Do it? Okay. Um, so yeah, I guess u is the real part of the function, so u is equal to minus y, v is equal to x. And so now just need to calculate these partial derivatives. So u sub x is going to be 0. Yeah, if it's not JEE, you can just put it there in chat or in my Discord. U sub y is going to be minus 1. And then v sub x is going to be 1. V sub y is going to be 0. The thing we need to verify is u sub x equals v sub y, so that checks out. And then v sub x is negative u sub y, so that also checks out. So this holds for all x and y, so I think that's kind of all there is to it. For the rail question, Nightlight, it's posted in my Discord. In the math homework help forum in Torque. Is there a program that would sketch conformal maps? Almost certainly. I don't know what it would be though. I wonder if like FizzBuzz would know. I mean, why would that be that's an equivalent way of writing this? Like, if like IZ is the same thing as I times X plus IY, so if you distribute it, you do get IX minus Y, which is the function they gave. They might just be citing that Z is an analytic function, and so a constant times Z is also analytic. But I feel like just checking the Cauchy-Riemann equations is really easy here. I guess that's also pretty easy, but if that's all the answer says, that f of z is IZ, they must be like using the fact that f of z equals z is analytic or holomorphic. Yeah. And you can post it if you want. I can't promise that I'll be able to do it. You can close it? Close what? No. I'm talking to someone else. To Aditya in the YouTube chat. No worries, Finbox. Um, to be honest, it's kind of a good thing we're calling it because I'm really sleepy to today, and on top of that, even if I wasn't sleepy, I just don't freaking get chapter 7, so I don't mind taking the day off. I'm looking at your question, Aditya. Newtons per Coulomb. Okay, yeah, that is a field. I thought it was potential at first. That's in. Uh, I don't know. I don't feel like I understand the theory until I solve problems. Like understanding the proof of something and understanding a theory are completely different things to me. And I don't understand the actual theory until I start to use it, I guess. So okay, so it's a uniform field. Okay, so I will solve part C. Approaches the other way, but you don't stay in one book. Okay, fair enough. Um, So I think let me work through A and B first because it seems like they're kind of related. If the potential of the origin is zero, the uniform field points in the positive x direction. Um, Frickin' what letters? Why am I forgetting this? Isn't it phi? It's going to be the field times distance, I think. My E&M's a little bit rusty. um, it is phi. So yeah, it's E integrated over path, I guess with a negative slapped on it. Um, the expression for the potential at a general point x, y, z. So phi should only depend on x, I think, because if you move in the y or z directions, you're moving perpendicular to the field, and that doesn't add any potential. Uh, and so is it just phi equals x? Sorry, yeah, 2 times x. So if we are, I might need a negative. Potential of the origin to be 0. If we move in the positive x direction, we're doing negative work. So we need a negative sign. Because you only do work when you only do positive work when you're going against the field. So you have to be moving in the negative x direction. Yeah, I think that should be the answer for part A. And so I think the answer for part B is that there's only one place where the potential is 25. I don't see how there can be a second place. But it would be oh wait, I know. I think I know what they mean. It's the x value has to be negative 25 over 2, but y and z can be anything they want to be. I think that's why they're saying points plural. I was thinking there's only one point because there's only one x value where you get what you want, but y and z could be anything you want. If potential of the origin is going to be 100 volts, will be the expression for the potential at a general point. Uh, I think this is the same thing as just like a function transformation. So this phi, I think, is going to be minus 2 times x minus 100, but I need to think about this. Might be x plus 100. I think it's plus I think it's plus 100. No. I think it, yeah, I think it's minus 100, but you could like multiply this out. Minus 2x plus 100. And I'm thinking about this because if we start getting into the negative at x's, we expect to be adding on to this 100 volts. And so we need this to be a positive number for negative x's, and that checks out. And then if we go in the positive x direction, the reverse is true, and we're going to start chipping away at that 100 volts. Thanks for posting that, Nightlight. I'll put it in Poison Mouse thread. Really? I apparently can't. Can I forward it? No? Okay, that's cool. I was gonna add Poison Mouse then. Oh, wait. I did this. uh I think ignore the first line. My keybinds are definitely wrong. I'm hitting the wrong keys. Uh what was on this key? Oh, pan. I know. Oh my god. Sorry, I need to fix my things, but the way that I'm thinking about this is that if we're setting the origin to be 100 volts, then if we move in the negative x direction, we're going to add on to the 100 volts. We're going to go like 101, 102, 103. And so this accomplishes that. And then if we move in the positive x direction, we're going to start chipping away at the 100 volts and eventually get into the negatives. So I think it's just simply minus 2x plus 100. The thing I wrote before with parentheses was completely wrong. Mr. Beast no, I don't think that's the voltage. It shouldn't depend on Y or Z. Okay, I fixed my keybinds. So yeah, Aditya, um, I don't know how else to explain it, to be honest, than the one I just did. I just know that it needs to fill certain requirements, and this is the function that does it, I guess. And the requirements are like, I expect in this region over here to have over 100 potential, and then in this region over here to have less than 100 and eventually going negative. And so I basically kind of like did this by guess and check. But yeah, I don't have a better explanation than that. I'm sorry. But yeah, it's kind of like you're given the potential of the origin is 100, and you have to make sure that it increases in negative x and decreases in positive, and that answer accomplishes that. There's probably maybe a more formulaic way of doing it, but that's how I think about it. Part D is kind of interesting to think about. I think we're going to get infinity, aren't we? Like, this is just going to diverge. Or maybe not. Maybe it does just diverge. I'm American Nightlight. Yeah, I think part D, there's probably a way that you can show with an integral, but I bet the answer is that it's going to be infinity. I guess it's only practical to take the point infinity to be 0 if the field drops off. But this is a uniform field, so you can't. It doesn't really do that. I look Nordic. My heritage, according to my parents, is Irish, Russian, and German. So I guess take that for what you will. I just saw Haru posted a nice comment in the Discord. Thank you for the kind words. Oh, and they deleted it. Okay, well, that's fine. Yeah. Okay, then in the meantime, we might go back to looking at complex analysis stuff. We do some more for number 4. I think we did A and C during the reading group, so we could look at the other ones. And this question, you're not supposed to use Cauchy-Riemann. They want you to use the limit definition of a derivative. I think, or how do we do the one for sine? I don't even remember. Hey, Krim. In calculus part for complex analysis, what about this is in, or like this is calculus, right? when is a function non-differentiable? I can talk about that. Just let me. Okay, yeah. Um, I think they often end up being the same, Krim, yeah. Hey, learn and grow up. So the function is not differentiable. Um, I'm talking about real single variable. I was just looking at a complex function. I assume you're not talking about that. Um, a function is not differentiable if it is not continuous and or it has a corner. So there's two scenarios to think about here. The first one is a little bit more clear, which is a discontinuity. So if you have a function that is like just like a step function, let's say, where there's really any sort of jump, it's not differentiable at this point, whatever that point happens to be. Because how the hell do you define a tangent line there? It's differentiable everywhere else, though. There's a distinction to be made there. The other scenario is if there's a corner. So like absolute value of x, right at that corner there, it's not differentiable because there's many different possible tangent lines. Infinitely many. So yeah, Papadori, it's not a very mathematical definition. I don't know what the exact definition even is, to be honest. Um, but in order to be differentiable, a function has to be continuous and has to be smooth. It's the opposite of what I wrote there. Yeah, those are the two situations to watch out for. Which course teaches all of this, Krim? Oh, the thing I was looking above is complex analysis. What's the question? Learn and grow up. Yeah, there's a few different ways you can define absolute value of x, but a nice way of saying it is like absolute value of x is equal to, like, as like a piecewise function. So with piecewise functions in particular, you have to, there's ways to check if they're differentiable. Yeah, I think the more precise definition is that if you have a piecewise function, you have to verify that the derivative of the of one of the functions has to equal the derivative of the other function at that point. That's probably the better definition of smooth. Yeah, what Dunlock said. Yeah, I guess like the limit as h approaches 0 from the left of your normal limit definition of a derivative should equal the limit as h approaches 0 from the right. That's probably the thing that Dunlock is going for here. That will be our condition for like being smooth, I guess. You know, I feel like I should make the YouTube slow mode not so bad. $30 might be a little bit overkill. I might end up regretting this, but let's put it down to like 15 seconds so people can type more. um, wouldn't y equals 1 for x and r without 0 be smooth? Well, yeah, y equals 1 is smooth. What's wrong with that? The horizontal line. The derivative would be 0 everywhere. Did the book give the complex definition of tangent? Function can be considered smooth even as a discontinuity. Oh, I see what you're saying, Papadoria. Uh, okay. So you're talking about a horizontal line, but you've removed that one point. Sorry, I kind of ignored your domain for x there. That's an interesting question. I guess it wouldn't be smooth there because it's not defined there. How can you be smooth where you're not defined? So I guess you do raise a point where the function does need to be defined there in order to possibly be smooth. You could have a tricky case where, oh my god. Okay, so imagine you cut a parabola in half. So actually, these conditions aren't enough. They're not or the condition up there isn't sufficient because you need to deal with this case. The derivatives do line up, but the actual function sells a discontinuity. You need to require that the limits of the actual thing are the same too. And even then, I think we would need a third condition to exclude Papadoria's counterexample there. Let me look at what Aditya posted. So it says x plus 1 when x is less than 0. Absolute value x minus 1 when x is greater than or equal to 0. And we're composing these functions. Oh my god. Okay, this is an interesting question. I bet we can use the chain rule to figure out how to do this. So the chain rule tells us that the derivative of that thing is g prime f of x times f prime, right? You left as soon as you saw it? Yeah. And so I think we can look just because of this. I think we can look just at the differentiability of g and just at the differentiability of f. And if either one of them aren't differentiable at the point, it should overall not be differentiable. Maybe there's a catch there, like if one of them is 0. But I would imagine if you have two functions multiplied together, if one of them isn't differentiable at a point, the overall thing probably isn't differentiable at a point. That's what I'm thinking. So I hope we can look just at f of x individually and just at g of x individually. We could also just compose them and deal with that. They do have the same intervals here. Honestly, that's not so bad. Maybe we should just do that. No, the greater than or equal to 0 is going to be weird. But let's do them individually. So looking at f of x here, this graph x plus 1 is going to look like that. And then absolute value x minus 1, well, x is, ooh. That's like the absolute value of x shifted to the right by 1. So it looks like that, right? It's like a stock. It still affects this little portion, Papadoria, where x is between 0 and 1, I think is why it's there. So f of x has two non-differentiable points. One of them here, one of them here. No, that took me a second too. I had the same thought go through my mind. But then g, the only place where g can possibly not be differentiable is right on the discontinuity. Because both of these functions individually are differentiable. 2 sleep is not going well. Oh no, Papadoria, you need sleep. You can still just draw this though. X plus 1 will look the same. Oh man, I think we do have to compose them to be safe. Because, okay, I really didn't want to compose them. I'm getting 3 for an ant. Oh, well, no, this is double counting. Neither of them are differentiable at 0. So I'm betting the answer is 2, because there should be one non-differentiable point at 0 and another one at 1. But I want to play it safe here and look at the composed version of these functions. Well, yeah, but I assume if we plug a corner into a smooth function, we're going to get a corner. I think so, Boys and Mouse. I haven't really tried it before. Um, no, looking at this, I feel like this is not going to be differentiable at 1. We can graph it, but I think the work that I did before is just fine. I don't want to multiply all this out. It sounds kind of annoying. Jacob, I can talk about that in a second. Okay, yeah, see? it's not differentiable at x equals 1. If you plug a corner into a smooth function, you do get a corner. So yeah, I'm saying the answer is 2. And I think the best way to do it is the analysis that we did like here, looking at them individually. Yeah, Papadori has given you the key thing to look into there, Jacob. The short version is that mathematicians were proving things about sets of numbers. So like the natural numbers, the rationals, the integers, and real numbers. And Cantor, the person who Papadoria is referring to, it's posted in the Discord, Poison Mouse. Keon, is there any restriction? I'm not sure what you mean by restriction. The thing you want to check is for any like jump discontinuities and for any corners. How can numbers be real if our eyes aren't real? Oh my god, mega. So Jacob, mathematicians were able to show that as sets, the size of the natural numbers is equal to the size of the integers is equal to the size of the rationals. I forget how you do this Q. I think something like that. But Cantor found that the set of real numbers is actually greater. And the weird thing is these are all infinite. So we know this thing is true, but they're both infinite, so we have to change our idea of infinity, basically. So we say this is countably infinite, and we say that the real numbers are uncountably infinite. Me when Q is dense in R over Q. And so I think mathematicians have since gone crazy with this notion, and they've started studying something called infinite ordinals, where you deal with levels of infinity beyond that too. I know very little about it though. Yeah, sure, Mouse. I remember this decently well. Like how you do these various proofs. Well, z equals q is a little bit weird. I don't remember that proof exactly, but I remember seeing Opie draw a really neat looking graph for how you do that mapping. Hey, Nikhil. No, I know the reference, Mega. Making fun of Jaden Smith is a real throwback. I always felt a little bit bad because he was a kid, and I definitely posted my fair share of cringe stuff on the internet when I was a kid. But it's also just kind of funny, so. Alex, you had a great time. School starts in 3 hours. You need some sleep. All right, get some sleep, Alex. Thanks for hanging out. Okay. So what I was doing before with the complex analysis stuff, I was looking into the book should say somewhere the complex definition of tangent, right? I could just figure it out for myself. Oh, you posted a new question? Let's see. Find the set of points for which these functions are continuous. Oh god, is this Dirichlet's? This looks like different versions of... I forget what the evolved version of Dirichlet's is. Where you get the triangles, but that function too. Determine the set of points for which the functions are continuous. Wire stress function, yeah. Papadoria. I'll be it for you maybe. Hey Sincope. No, I was saying this looks like oh, it's not quite Dirichlet's function. This one is Dirichlet's function. And it's apparently a pretty common counterexample for some analysis stuff that I don't remember what exactly. Oh, well, spoiler alert. CYNX. Before taking out Cus 1, should I know all of that problem? No. This is something you would do after calculus normally. Okay, let's start with part A though, because part A is different. Okay, so I think for part A we should graph. One, two, three. 1, 2, 3. So the natural numbers. Oh. Okay, so Poison Mouse, there is debate whether the natural numbers start from 0 or from 1. I think in math it's more common to start from 1. Okay. So yeah, we'll start. We'll say the natural numbers start from 1 then. So that means at 1, 2, and 3, and so on, all the way out to the right at those points, we have 0 exactly. But everywhere else we have 1. Until 2026, and is there like a law about that? What the hell? But between the natural numbers we get 1. That's kind of crazy. So everywhere between the natural numbers we get 1, and everywhere to the left of 1 we get 1. Math as well, apparently, yeah. So just by looking at the graph, it looks like we're continuous everywhere except the natural numbers. So I think that's my answer for part A. That's at least, I mean, that's still a little bit like heavy-handed, it feels like, but that's more reasonable than, I think it was Illinois or whatever American state made a law that says pi is equal to 3 or something. Okay, for part B, let's do another graph. Coming to see you're a scholar? Okay. So here, at the natural numbers, we're equal to x. So at 1, we have 1. At 2, we have 2. 3, we have 3. But otherwise, oh, it looks really similar as this, but shifted down to 0. So this is kind of lame, to be honest. There's a cooler version of this question they could have asked. Slightly cooler, at least. I think we're getting basically the same thing here. We have a different function, but it's really just the same behavior in terms of continuity. Like, the only thing that really matters here is that that these jumps exist here. It doesn't matter how the jumps exactly look like. All right, see ya, Aditya. Thank you for the questions. So I'm getting the same answer here for part B. Now for part C, it's not really possible to accurately graph that. Because there's just there's basically, I think you can say between every pair of rational numbers there is an irrational number. Like, there's just way too many numbers here to deal with to be able to accurately draw. It's just gonna, if you plugged it into a computer program, it would look just like two horizontal lines because they're just so close together. But they're not exactly horizontal lines. They're individual points that do have separations. And so I told you the name of the function earlier. This one is the Dirichlet function. So this one is going to be nowhere continuous. Also, between every irrational number there is a rational. Okay, that's good to know too. Popular. I didn't think about the reverse of that. Oh, I guess that would be implied by the first thing, though, right? If between every... No, actually, it wouldn't be. There could be two irrationals between a pair of rationals, so you have to exclude that. Okay, yeah. Oh, does Dirichlet have the 0 and the 1 switched? Oh, it does. Yeah. I think the concept still applies. But yeah, you're right. I didn't realize that Dirichlet has the 0 and the 1 switched. Oh, I'm hoping they're not asking us to prove anything. I'd have to look up a proof. Osman, I see your question. I might be able to figure it out. Well, I think something got lost in the copy paste there. So I'm not quite sure what function or what vector field it is. No? Okay, so I assume there's no proof needed. And then I think this one, I think for the same logic, it's going to be nowhere. Because... Yeah, it shouldn't be continuous anywhere kind of by the same logic. At 0? I was just wondering about zero. I really? There's a neighborhood there? I thought there wouldn't be. Y equals S can approximate zero. Sure, Papadoria. Really? Huh. I can sort of see that where they're it might only be like a 1 point wide neighborhood, I guess. But if zero is a rational number, I guess on either side, you would have one irrational number that's trying to form the line y equals x squared times h of x. It's continuous and differentiable at zero. Okay. Oh, I see what you mean with that, Osman. Okay. Those are the basis vectors. Um, let's see if we can figure this out. My Flux is a little bit rusty. Um, yeah, this should have a flux, right? Because the origin is going to be a source for this vector field. It's like I expect a positive flux, I guess. Um, it is closed Poisson mass, but it contains a source, so it's going to it will have an outgoing flux. Uh, calculating flux. So we might need to do like the sides of the cylinder separately from the top and bottom of the cylinder. I I don't know how to use Gauss's in general math. I only learned in the context of EM. I guess the divergence theorem is a better thing to Google here. So the divergence theorem says that okay, yeah, I'm pretty sure we can use this here. For a closed surface like this, we can translate this flux integral into just a regular triple integral over the volume. Cylindrical coordinates probably a good idea, yeah. So the divergence of f is it's the partial in x of the x component plus the, let me just remember. It's delta dot f. Yeah. So or del dot f. So we take the x component, take the partial with respect to x, that's one. Take the y component, the partial with respect to y, that's one. Really? That feels like a very simple divergence. On YouTube, I don't get paid anything because my channel doesn't qualify. On Twitch, I get paid a little bit. That's weird that divergence is just two. Shouldn't it just depend on the... it feels weird that it doesn't depend on x and y, but I don't have good intuition for the divergence. Um, but yeah, I like the idea of using cylindrical coordinates here, Osman. I need to remember the Jacobian for cylindrical. I enjoy it. 849er. It's just RDZ. Okay, yeah. So 2R, we say dr d theta dz. So R is going to go from 0 to 1. Theta goes 0 to 2 pi. Z goes 0 to 2. And I think that this is just a normal triple integral now, and we can just evaluate it. Yeah, Poison Mouse. Good call with the divergence theorem. The hard way of doing this is you basically have to find a function that represents a normal vector for the surface, dot it with the original function, and then you would integrate around that. That's the more general way of doing it, but this can save time. Answer should be 4 pi. Okay, let's find out. That just evaluates to 1. That's just 2 pi dz, and then this is just 4 pi. Hell yeah, so we got the right answer. Chaotic Diamond, yeah, there's one question before you, I think, from Papadoria. You done your test? Oh, nice. How do we get 2R as the integrand? Okay, so if we're using the divergence theorem here, the 2 came from the divergence of f. So the 2 is the divergence of f, and then the r is the if you're using cylindrical coordinates, that's where the r It's the Jacobian is like the more general word. But if you're doing an integral in cylindrical coordinates, you need that r there all the time. So they're there for separate reasons. But yeah, Chaotic Diamond, for reason, like just go ahead and post your question. The R just randomly spawns. Yeah, basically, Osmond. There's a reason why it's there, but for the sake of actually doing this, it randomly spawns there. You just have to remember if you're doing cylindrical coordinates that it's there. No worries. Thank you for the question. Freddie, yeah. I'll still be streaming over summer. Yeah, math discussion is fine. DKF is on. I'm bummed I'm gonna miss the stream, but I don't think I'm gonna end my stream for it. I want to watch it. For anyone who doesn't know, the Knowledge Fellowship, which I'm a part of, has been doing streams on its channel where they showcase different streamers. And I believe they're showing an astronomy streamer today. So I encourage you guys to check it out. I think I still want to do my math thing at least for a bit more, but that is a cool thing that's happening over there. Star Trader, right? Oh, we might do Chaotic Diamonds question I've seen before. That might be a quick one that we can do first. Yeah, I think Chaotic Diamonds question is quicker, so I'm going to do this one first because I know how to do it. Okay, so... And then Papadoria will be next. So the ball drops 12 feet for the first bounce. Oh, wait. Okay, there's a slight trick to these questions. So drawing out the path of the ball, it drops 12 feet. And then it bounces up to 2/3 of the height and it comes back down. It travels this distance twice though, because it goes up and then it comes down. So the first bounce is like a half bounce. All the other bounces after are normal bounces. And the question, the phrasing of it is a little... The total distance, technically we need to calculate that arc length there, but I don't think they're asking for that. I think they're asking for just horizontal distance. Oh, wait. No, I'm sorry. It's just bouncing straight up and down. So, yeah, it gets dropped from 12 feet just one direction. Then it travels up by 2/3 of that and back down by the same amount. So it's going to be 12 from that first dropping plus twice of 2/3 of 12, whatever that may be, which we'll calculate in a second. And then we'll have twice of 2/3 of the last thing. So 2/3 times 2/3 of 12. And this pattern is going to continue where we just keep multiplying by 2/3. Yes, it is going to, this is a geometric sequence. We have to exclude the first term from the pattern, but other than that, yes. So if we factor things out, the 12 out here, I'm just going to leave it alone because it kind of breaks the pattern. But everything else here, I'm going to factor out the 2 and the 12. So 24 times 2/3 plus 2/3 squared, because we have two of them being multiplied, plus 2/3 cubed plus 2/3 to the fourth, and so on like that. And the point here is that this is a geometric series. It has a known formula for the sum. I'll rewrite it in a more familiar form that might help even more. Two-thirds times 2/3 to the n. You could write this in a slightly different way too, but the formula for a geometric sequence, if the first thing is a and the thing inside the parentheses is r, the sum is a over 1 minus r. So we can do 12 plus 24 times 2/3 divided by 1 minus 2/3, and just solve this now. So 1 minus 2/3 is 1/3. The 1/3s cancel in this fraction, so you just end up with 2. Oh, true, Papadori. You do need the absolute value of r to be less than 1. And that's true because we have 2/3. And then now that's 48 plus 12 is 60. So calculator, I'm getting 60 for the answer here. I'm sorry, I was muted because I drank water and I didn't unmute. We're just dropping the ball straight down. So it's bouncing up and down. So when we first drop it, it travels 12 feet. Yeah. And then it bounces up. You can check your speaker. Yeah, sorry, Papadoria. 2/3 of 12 is 8. So it then bounces up 8 feet and comes back down the same distance. Then it bounces up 2/3 of 8, which is not a clean number, 16 over 3, and comes back down by the same amount. So the pattern that we're getting here, like this 12 is kind of an outlier because it only happens once. But the goal is to add all of these distances up. So we get a 12, we get 2 8s, we get 2 16 over 3s, and we're going to get 2 of whatever 2/3 of that is, and 2/3 of that. So that's what the pattern is here. And instead of actually doing 8, I was doing just 12 times 2/3 and not worrying about the actual math. So 2/3 times 12, that's what 2/3 of 12 is. We don't need to bother actually finding what that is. And then we have 2/3 of the last thing, so we multiply by 2/3 again. That's where this pattern of multiplying by 2/3 comes from. And then the trick is you ignore this first 12 because it doesn't follow the same pattern. But from everything else, we can factor out the 2 and the 12. So that's 24. Yeah, exactly. But that's the trick with these problems, is that first 12 is it breaks the pattern. So you have to deal with it separately. No worries. So yeah, I'll leave it there then, but let me know if you need anything else with that question. I'm sorry, and Devin, I saw your question. Uh, I can screenshot them for you. And put in the Discord. Hopefully it's readable. Actually, Devin, I'm not sure that's the entire question. I'm not sure. I might be able to do it, but I'm not sure where the question is going exactly. Well, we probably want to make this, probably want to translate these into logarithmic form. My y's and 4's look pretty similar. uh, Thank you, Rayan. Uh, I'm not too good at making videos, I feel like. Oh, sounds good, Osman. Thank you. Um, Now what? Ooh, isn't there a formula? Oh no, never mind. I guess so, Papadoria. I'm we could get everything in base X, I guess. Testing inertia, yeah. Um, all right. See you, Poison Mouse. We do have log base x of z here, log base x of z there. Rayan, I see your question. I want to work on this one for a bit more, but you can be after. Okay, so okay, I want to I don't want to write it all out, but I'm going to take this equation, multiply or like get the log base x of y to the other side, and then with this thing for log base x of z, plug it in down here and just see what happens. I want to skip straight to the plugging in step though, because I don't feel like writing this all out. This is something, right? That's just 3? I am not, I've never learned about tensors, Prem. So log base x of y is root 3, plus or minus. Probably plus, if they're more than 1. And Nagata Uchiha, I see your question. It might have gotten a little butchered by the YouTube chat. So I'm not quite sure how that reads. Sorry about that. You wrote the original problem down wrong in your paper? Oh no. Uh, do I have the right version of the problem? So I think now we might be able to just solve it. Because, like this equation here, right? This is a pretty annoying answer, but okay. Yeah. In that case, maybe I'll leave it there because we're getting some other questions, and if you know where to, I assume you know where to take it from here. Log base. Oh, it does. I didn't even realize that. I thought they actually wanted X, Y, and Z. Okay, I think Rihanna's next. I hope I'm not forgetting anyone who asked it first. Or at least Devin's question didn't seem complete, so I don't think there's anything else. Yeah, they would be. So just a warning, my multivariable calculus isn't... it's pretty rusty, so I need to look things up. So I think we can check if a vector field is conservative by looking at certain partials. That's for 2 dimensions. Yeah, we probably need to just check the kernel 0, you're right. I do believe that's the definition. So we can do that. Curl is del cross F. So IJK, your partials, y minus z squared, I assume, z cubed plus x, three yz squared plus 2xz plus 4. Okay, I see you, God of Uchiha. Thank you for writing that out. I can do that. It'll take a little bit of time, but you can be up next. And then Dino Nuggies, feel free to post your question and you can be third in line. Mohammed, no worries. Thank you for asking. You like pancakes? Pancakes are pretty good. Okay, so curl. Oh, thank you, Rayon. Plus d dx y minus z squared dy z cubed plus x k hat. Okay. Ooh, I forgot the j hat there. I guess I am, yeah. Group theory? Oh, I only know really basic group theory. Abstract algebra isn't my strong suit. If it was something that's pretty early on in group theory, then I think so. But I've hardly studied abstract algebra. Okay, so the partial of this in y. We have a 3z squared. That's it. Minus partial of that in z. Minus 3z squared. That's a great sign. That's 0. Oh my god, why did I write that? That's a brain fart. Partial of that in x is 2z. Partial of that in z is minus 2z. Great. Partial of that in x is 1. Partial of that in y is 1. Nice. So we do indeed get 0. So that this thing is conservative. Signature of a permutation group. Signature? I think there's a sign of a permutation group. I might be able to. I might remember that. There's a bit of a queue that's been forming. You would, if Dino Nuggies posts, or I need to work on God of Chia, and then if Dino Nuggies posts their question, I'll work on that one, and then you would be after. Okay, so curl is 0. That does mean that it's conservative. Now they want us to find a potential function for this. Basically, when they ask you to find a potential function, you think of this as the result of a gradient. So that means that whatever the first component is was the result of a partial in terms of x. This was the result of a partial in terms of y. That was the partial in terms of z. So if the original function is small f, the partial in x should be y minus z squared. And so we can integrate each side with x to see what that looks like. It'll be, that'll become xy plus minus xz squared plus some constant, technically maybe in y and z. Then z cubed plus x is the result of the partial in terms of y. So if you integrate each side with respect to y, here we get yz cubed plus xy plus some other constant that's a function of x and z. And then finally, the last part was the result of a partial in terms of z, 3yz squared minus 2xz plus 4. So integrate this in z, and we would get f is yz cubed minus xz squared plus 4z, plus some other functions. Okay, so now f needs to simultaneously look like all of these things at once, basically. So what we do is we look at the things in common. Because I don't know how to do them. So we have an x and a y there, or like an xy there. So our function needs that xy. We have a yz cubed. We need that. We basically kind of take one of everything. We need the minus xz squared. And then we need this 4z here. And we can still have just a regular constant. That's just a number this time. That's this part I probably could be explaining better, but you kind of look at what's in common between these and you just take one of them. It's the right answer? Okay, awesome. I'm glad. So yeah, thank you for the question. So Dino Nuggets, post your question if you have it, please. Otherwise, I'm going to start looking up this permutation. No, I'm sorry. God of Uchiha. My eyes just skipped right over that. So God of Uchiha. Y is root x squared plus 1 minus root x squared minus 1. Oh no. Is all of it over this? I assume it's like one big fraction. Well, look, it looks like something crazy. I don't know. Okay, before we think about taking the derivative of this, I would rationalize it. That'll probably lead to simplifications. And Gadabuchia, if you're still here, please tell me if I've written down the function correctly. It really is chaotic diamond, yeah. Yes? Okay, thank you. So on top, we get x squared plus 1 minus 2 root x squared plus 1 times x squared minus 1 minus x squared minus 1 over x squared plus 1 minus x squared minus 1. Dino Nuggies, okay. Thank you for posting that. We can definitely do that uh, after this. Right. We're getting to that part, God of Uchiha. I'm just trying to simplify it first before we take the derivative, because it's going to be a lot easier if we do. Um, okay, so we get some cancellations here. X squared minus x squared is 0. 1 minus negative 1 is 2. Minus 2 root. I'm going to multiply out the inside. X squared minus x squared is 0. Then we get a 2. So this is boiled down to 1 minus root x to the 4th minus 1. That's way easier to take a derivative. So from here, I would do d by dx of each side. And so the 1 just goes to 0. We're getting a negative. We're power rule, so 1/2 times 1 over root x to the 4th minus 1, and then chain rule times 4x cubed. So we end up with a negative 2x cubed over root x to the 4th minus 1. So you have an extra 2x in front here that I don't have. Did I make a mistake? Anyways, I wasn't showing my screen there. I am missing something. Well, uh, Mulik, that's a little too general. If you want some help with integration, I can recommend this website. Just look in the sidebar. If you want just the basics, then look in chapter 1 for integral. Hey, Sumya. Oh my gosh, I have too many tabs open. I put the link there in chat, Mulik. So yeah, Kadochi, I'm not sure where I went wrong here. I apparently missed... There should be an x squared floating around here somewhere. And I'm not sure where. Renga, was basically to take the derivative of this thing here, which is just annoying. And so I made a mistake where I think this one here should be an x squared. I don't see how though. Oh, is this a plus? It is a plus. Well, there's your problem. Okay, so that becomes a 2x squared. And so that becomes an x squared there. Okay, there we go. I just flipped the sign by accident. Got it with Chiha. Now my answer is going to match up. So that one should be an x squared. Two x. Okay. So yeah, got it with Chiha. That was the only mistake. I just flipped the sign where I shouldn't have. I hope that helps. All right, time for Dino Nuggies. Thank you for the question. Okay, so Dino Nuggies, you have, starting with your first equation, 2x plus 4 is 122. You're saying what is x thing? Like you're asking what x is whatever number makes this equation true. We want a number x that if you multiply it by 2 and add 4, you get 122. That's all x is here. And we can figure out what x must be if we do algebra. So we want to isolate x. So the first thing to do is get rid of this plus 4. So let's subtract 4 from each side of the equation. That's something that we're allowed to do. On the left side, we get 2x. On the right side, we get 118. Now we can divide each side by 2 to get rid of the 2. So those 2's cancel. On the right side, we get 59. So that's how you would find x here. Second question has a lot smaller numbers, which is nice. X plus 4 equals 12. From here, we can just subtract 4 from each side, and we'll get the answer right off the bat, which is 8. So yeah, I hope that helps. Dino Nuggies, let me know if you have any questions about that. And then nobody, it's some of the signature of a permutation group, which I don't remember. I was wondering if that's a typo for sign. Oh, it's not a typo. It's a word that I haven't heard of. Or it's it does mean sign. I just had never heard it called signature, but it's valid too. Um, I remember learning about this. I'm trying to remember what it means though. Where's that abstract algebra book? Here it is. Product formula doesn't always end up in a plus or minus one like it's supposed to. Oh, what's the formula? I don't know if a formula wouldn't result in one or minus one. I thought it's just basically negative one to a power. Do you know the name of the formula that you're talking about? Really? Um, so maybe that's an algorithm. Dude, I have to use the bathroom so bad. All right, I'm sorry, guys. I'm gonna go pee quick. I'll be right back. Okay, much better. Hey, Naman. So yeah, the product of f of I minus j, or f of I minus f of j over I minus j. I haven't heard of this formula. This looks almost like that. Thank you, Papadoria, for working on that question. Do the answer count the number of inversions, but the formula isn't helping? Yeah, I don't quite know what the formula is supposed to accomplish. It feels more like an algorithm that tries to compute it faster than that. Like it maybe feels like an approximation. I can't really find anything about it though. So I could in general find the sign of a permutation nobody, but I don't know how to use the formula that you put there. So the way that I would do it is counting the number of swaps, right? Um, I don't know how to use the formula that you put though. So if you want to just see the counting number of swaps way, I can remember how to do that. Um, I don't know another way of doing it though. That'll help. Okay. So let me remember how this works again. Oh, I forgot. There's a terrible thing with this where some people use different conventions. Uh, so we go from right to left. I don't think I know the answer to that question. But I think there's also another convention where you go from left to right. So just that's something to be aware of. The way I was taught was going from right to left, though. um, uh, okay, I think I remember how to do this. So the example that you gave was this permutation here. So I believe we read this from right to left, and we want to figure out what the individual swaps are. So if we start by thinking about 1. This doesn't involve 1. This sends 1 to 2. So I think the first thing we get is just... This feels wrong. No, I'm still... I'm sorry, I'm getting... God. I'm getting a little bit confused by this. I don't remember exactly how this works now. Because these cycles are already disjoint. The thing I was about to do doesn't make any sense. And if they are disjoint, we should be able to go directly to counting the sign, right? Wait, no, so you can write everything as 2 cycles. Look, no, I have a bachelor's. I'm starting on a master's in September. Okay, so we do break down to 2 cycles. Okay. And the number of 2 cycles determines odd or even. Oh my god, okay. So how does this work then? Thank you for the for the good lucks. Thank you for the prompt here, Lubert. I started with 1 and 2. Where does 2 go? It goes to 4. One, 4. And then 4 goes to 3. So isn't it like this where we always start with like, oh, you like kind of choose the first one arbitrarily. You could choose another one, and then you kind of break it out like this. Yeah, so if you get an even number of transpositions, it's even. If you get an odd number of transpositions, it's odd. And then I guess 5, 6 is already... It's already fine. So wait, does this make sense? So 1 gets sent to 2. Wait, aren't I sending 1 to 3 here? This feels wrong. I believe even is +1, odd is -1. Oh wait, I'm reading this backwards. We're going from right to left. So if we enter in a 2, the 2 gets sent to 1, then that 1 gets sent to the 4, and then we're good. If we enter a 1, it gets sent to 2, and then we're good. If we enter a 4, it gets sent to 1. Okay, yeah, so this... Okay. So this is... Thank you for that, Lubert. Let me verify the sign bit. I'm pretty sure even is +1, odd is -1, but looking back at this PDF. Actually, maybe the Wikipedia page is better. Yeah, +1 is even, -1 is odd. It's been a minute since I've done this. I should really study more abstract algebra. Ugh, I just have too many other things to work on. But yeah, so nobody, I think I understand this a little bit better now. If you want to understand this like decomposition process, I can try and explain it again from scratch, but I don't know how you feel about this. Like if you're to feel like you understand it, then I won't bother. I mean, my only guess is that the formula would be helpful if it can calculate it faster than having to do this decomposition process. It does take a long time. So the formula might be good for that purpose if it somehow does it faster. But I don't really understand how the formula is supposed to work. Pure math sometimes feels like social study. Mode, a bag? That's an interesting question. I don't know if I know it. No worries, nobody. Thank you for the question. Sorry I couldn't do a better job of it. This is probably the last question of the day, or even then I'm not able to figure this out, but 4 a.m. Yeah, you better take a break. Jeez. Oh. I don't understand this. If the probability of drawing out two black balls is a third, aren't there just two black balls and there can't be five? I don't understand what I'm missing. Like, let me think that the probability of the bag having at least five black balls was 0. Yeah, I'm sorry, Mode. I'm not sure how to do this question, and to be honest, I kind of want to wrap it up for the day. It seems like the answer is zero, but I feel like I'm missing something. Like I feel like it just means that there's two black balls in the bag, the first part of the question. So I don't know what to think about this. It would be 2 6 times 1 6. Oh, I mean you can rephrase it if you want, but I guess Luber's making a good point. You made a real mistake there? Oh, wait, yeah. If you made a mistake, please rephrase it, especially. Oh, a fifth, yeah, right. Uber. There's no way that if there's there can't be six black balls, because that would mean the probability of drawing two is one. If there's five, there's no way in hell the probability is only a third. It should be way bigger. So, hey Hamna. So, mode it. I guess we need to wait to hear the rephrase version. But ideally, we hear it relatively soon because I don't want to stream for too much longer. This was the actual. This is the actual question. Okay, it still doesn't make sense. It still would make no sense to me that the probability of getting two black balls is only a third if 5 out of 6 of them are black. And if there's 6 out of 6, the probability should be one. So I don't think it can be that. I'll Google and see if I'm someone on the internet has done this, but I don't get this. Thank you, Hamna. Uh, oh, it's more like this. That makes more sense what the question is asking then. I have no clue what this solution means though. Like how you would get it. I need some more explaining there. It's okay mode. Um, I'm not sure how to do the question, but I at least understand what it's asking now. uh, so it's more like I guess grab. I don't know, draw is fine. So the question I think is more like that. um, so to be honest, I'm not sure I do a probability question like this. And I can't find the exact one being done that's not behind a paywall. Oh wait, maybe this isn't behind a paywall. This one is saying 5 out of 7. Oh, it's a Bayes theorem. Really? Huh. I was wondering about Bayes' theorem. I'm just way too bad at the probability questions to recognize it or like to be more certain about it. Hey, Kushal. Hmm. Wait, that's 3 out of 5. Is this some AI shit? Up here that says the answer is 5 out of 7. Down here it says 3 out of 5. Bayes' theorem does feel like a good call. Yeah, that definitely looks like an AI solution. But it might be right about the Bayes' theorem thing. Uh, Kushal, I'm sorry. I'm gonna end the stream after this, but I don't know how to do that like well. Or I, 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 I can't talk. I'm getting really tired, but I don't know what kind of problem you're looking for. I'm sorry. A is the probability of at least 5 black balls. B is given at least 2 black balls, I guess. No, I'm not even setting this up right. Hey Joel. GR, I'm sorry. This is the last problem of the day. I'm sorry, Joel. I'm ending the stream after this. I can post it to the Discord and I'll get back to you another time, but I'm really tired. No, I don't think I'm choosing the right A and B here, and I don't know how to phrase it. I'm sorry, Mode. I just don't think I can do this question. It does have a Bayes theorem feel, but I suck with probability and I'm tired, so yeah. I think I'm just gonna wrap things up here. Yeah, Joel, with a double ring, puts in the Discord if you want, or catch me the next time. GR, your limit thing, I don't know. But yeah, everyone. So on YouTube, I'm gonna end the stream. On Twitch, I'm gonna raid out. So when people are here on YouTube, thanks for being here. We're back on Tuesday. So goodbye, YouTube.